Welcome back to Maths with Mrs. J. I want to introduce you to the change of base rule, and I want to do a quick proof. In future videos, we will be actually using this rule, so don't get too panicked now about the fact that it's all very theoretical. Just a couple of words before we start. Why would we want to change base? Well, in previous examples, we might have had something like log of 32 to base 4. And for something like that at this stage, before you know the change of base rule, you would have to convert that into index notation and go from there. Because 32 is not 4 raised to an integer. However, 32 is a power of 2 and 4 is a power of 2. So if you know the change of base rule and you were to change to base 2, that would work and would save you having to go back to integers. The other main bases that you will tend to change to, or the reason that you would change, would be to say base 10. Say you wanted to know log of 8 to base 3, an approximation for that. Clearly we can't get an exact answer for that because 3 to the 1 is 3, 3 squared is 9, and so it's going to be a little bit less than 2. If we change to base 10, we can use our calculator to get an approximation for that, however. The other main base that we tend to change to is logs to base e, mainly because of the differentiation properties of our natural logs. So whatever it happened to be, whether that's x or y or whatever, okay? The way I remember this rule is whatever your number here is, see how it's higher up than the n? That's why the m goes in your numerator and the n goes in the denominator. Well, it's not why, but that's how I remember it. Very unmathematical way of remembering it, but if it helps you remember the rule, then all good, all right? So whatever base you're changing to, that's got to be the same in numerator and denominator. You can't change base to base 10 in the numerator and into base 8 in the denominator. It's not going to work. And then the m and the n go like that. Let's do a quick proof. I'm going to let log of m to base a be x. So this bit here is x, and let log of n to base a be y. All right. So of course the index version of these are that a to the x is m and a to the y is n. Let's sub both these bits of information into our original. And so we've got to the point where we've said log of m to base n is really x on y, if we're calling them x and y. I might call that bit of information number 3. All right, completely separately, and you'll see why I'm doing this in a minute. Let's work out n to the x on y. Why would I want to do that? Well, have a look at the log notation there. N is your base, x on y is your index. If we can get this to equal m, then we've basically proved the formula. All right, n to the x on y. Okay, well, n is a to the y. So this is a to the y to the x on y. Just saying that again, I've just replaced, let me just, so n I've replaced by a to the y. Yep. Okay. Now, we know with index laws that if you have a power of a power, we multiply the indices. Y times x on y is just x. So this is a to the x. All right, let me just do a bit of working down here. So y times x on y, there's really a 1 there. The y's cancel and you're just left with x. But a to the x is m. All right, we know that because that's how we defined our x to start with. We said x was log of m to base a. So we can put this information into log form. So log of m to base n is x on y, call that information 4, well, we've proved it, haven't we? So 3 and 4 tell us that our change of base rule works, that log of m to base n is the same as log of m to some base a over log of n to some base a. And normally you'll pick that a to be either something that both of those can be written as powers of, or it would be base 10 if you're going to use your calculator, or if you're differentiating, it will be base e.